And let's see if I can do this without any more interruptions. And this is an order from my wife. She wants pictures. Okay. Okay, now, what this is about is it's based on a talk that I did a couple of years back for a sysadmin user conference. And originally the talk was about 20 minutes long because most of the people wouldn't have had any idea what I was talking about if I'd actually gone into the guts of it. It's also based, before that, on a contract that I did for a Seattle company that had a 2 terabyte database system that was the semantic backend for the Washington Post. So this was actually a real issue, and it was a very messy issue, and they were in a big panic. So what I'm going to do is I'm going to go through the routine of what this is. Essentially, hardware damage. So let's see if my screen can work here. There we go. All right, so I'm going to go through this very, very quickly because I burned up a lot of minutes getting this thing to work properly. I've been involved with Postgres per se since about 2002 when I went to a conference, an open source conference in Ottawa, where one of the core members at the time, Mark Fournier, was there. And I was looking for a direction. I had been working with Linux since '96. And I said, OK, let's commit ourselves to Postgres. And it worked from there. In 2004, I met Bruce, when at the time he was working at SRA. And from there, I worked in. I got more involved with the community. My professional career has been actually 100% open source. I've gotten my paycheck because I've been part of the community. I got people interested in me because they saw what could be done with Postgres, and they could verify that this is what you did. So that being said, my current place of work is a place called Asurion. Now, most of you may not know this company, except until you realize that when you go and buy your cell phone, the last thing those people ask you is, do you want insurance? That's these guys. They basically control every cell phone insurance in the Western world. When I studied to get this job with these people, they had a population of something like 10,000, which is 2012, 2013 current information. The CEO came and did a nice how-to-do introduction about a month after I started working. They had grown up 3,000. They were at 3,000 now. So at 13,000. So it's a very, very fast growing. The biggest sector in IT right now is mobile. And the biggest thing about mobile is analytics. And they're talking about NoSQL and big data. And the biggest thing that most of these people don't realize is how powerful Postgres can be in this environment. If you know what you're doing in Postgres, take it from me, there is an opportunity here. And that's because they don't know it, so there's no crowd. You've got an opportunity, take advantage. So let's go into the guts of this. Postgres is a very, very secure environment. It's secure because it follows a standard protocol. What to do when something happens. How to deal with information. Under ideal conditions, the worst scenario that you can go under is that you have lost a transaction. That's it, under conventional use. But there is that aspect of Postgres that you can't control, the hardware. Now, I'm operating from a point of view of prejudice. As far as I'm concerned, if you have the top DBAs of the major different industries, of the major different products, SQL Server, DB2, Oracle, hands down, I would say that the top people of Postgres know twice as much about database and information and the whole system opposed to any other DBA. And part of it is how it sets out to do things. Postgres does what it does. It is a database system. Oracle is a company which supplies an ecosystem which answers to shareholders. Microsoft is a failing company that's going to die in a few years. So, that being said, the problem that we have is what we can't control, hardware. Something's going to break. Now, we've done as best as we can to protect information by configuring it. DBAs eventually, sooner or later, when they feel comfortable enough in their knowledge, they're going to start getting involved in hardware. So they develop an appreciation of hardware. They look at RAIDs. They look at all the devices. They look at all the little doohickeys. They get involved and talk with the vendors. You find out and you develop an appreciation. But this appreciation doesn't mean much if you don't know enough about Postgres. Now, it isn't about knowing everything. It's about knowing little pieces of information and expanding on that realization, on that knowledge. When you get an accident, like in this particular case, the situation that I'm dealing with is RAM. This scenario is about RAM, and it's about one specific set of information, one way to remedy it. There are many ways. Anybody who's creative can come up with an effective recipe, and I'm the first one to admit that there are possibly a number of people here present that could come up with ways and methods that are even more effective and easier than what I'm about to show. What I'd like to do is to get through the message is that I'm going to show you an idea, I'm going to show you what it is, and wow, it is easy to do. What it is, it's realization. So I'm going to ask you this question. Which one's the DBA? I mean, you're going to have a disaster, and you got two ways of reacting. You're either the victim or you want to thump somebody. So it's a very complicated, very emotional state in a production environment. When you get a failure hardware, it's really easy with something that collapses, okay? All right, you're expecting it. But something as insidious as RAM, this is very, very poisonous. It's very dangerous, and it only occurs over a long period of time. The company that called me in, they didn't realize they had bad RAM for some time. And when it happened, their first objective was, okay, let's just take the dumps and restore it on our standby machine and then bring that up to speed, which what every reasonable company does, except the dumps were corrupted. Once the RAM went bad, there was no way to tell that the information that was being stored was bad either. So you got this question like 2 terabytes, that's a lot of information. You know, there's an expression, a hammer sees everything as a nail. You just work very, very hard, and you'll figure it out. There are ways to solve this problem through conventional means. You could parse out your dumps. You could do incremental loads and figure things out slowly. I'm not saying it can't be done. I'm saying this is a way. This is a hammer. And this, by the way, is where I'm going to introduce you to my teaching aid. For anybody who's really geeky, you're going to understand that in another second. As I said, for a hammer, everything seems to be a nail. Well, all right, let's consider the tool. Maybe the approach is to change the tool. Maybe you got to think differently about something. Maybe what you need is a screwdriver. Okay? It's how you look at something. A little piece of knowledge, I want to get this home because actually what I'm going to show you is really simple and straightforward. I just want to get this home, this simple idea home to you across. It's a little piece of knowledge, a little piece of leverage. Be creative, expand on that knowledge that you are certain is correct, and you can improvise. You can create a solution out of nothing. The secret is really simple. And at this point, anybody who's been a seasoned DBA, I could actually technically stop here. How many people have actually looked at the cluster and studied it? All right. A data cluster is a set of files. Postgres is one of the unique relational database systems that isolates everything as individual files. And because of that, you can solve things. Solve particular problems. Every number is an identity of a relation. Postgres has a set of what are called system catalogs. They are the implementation of industry standard rules. And because they are exposed, you are in the position of warping those rules. Now, we're not going to go too far into it, but I'm saying it's there. A directory is basically the name of a database. So when you see a folder with a number inside it, it's probably a database defined. And all those relations below it are the tables, the indexes, the sequences. Here's a little example. I'm going to create a table, T1. You put a sequence to it by using a data type serial. It's going to be a primary key. So what you've got, because you're using a primary key, you're associating an index. So you've got three different entities. You've got the table, you've got the index, you've got the sequence. Three different things that are saved to the hard drive for this particular table. Look at the bottom. This is our first real use of the system catalog. We have the relation file node. Oops, right over here. Right there. Those are the actual names of where that information lies in the directory. They're actually physical, tangible stuff. So again, we build on simple understandings, step by step by step. So you write down here at the bottom, I show using find, and you can see when I have the reference, the relation file node, I can find out where they are physically. And you see this first set of numbers in between? That's the database. That's the actual object identification number for the database. Let's break the system. I am going to erase the sequence. I'm going to move it out. So how does it show up? How does the manifestation breaking show up? Well, if you were to do this on your own, and I really encourage you because this is how you're going to learn the system. One of the first things you're going to learn is it doesn't break. That's because the system has it in memory. This is such a small table. The relations are so small. Everything's in memory. It's going to pretend and work right along. You can do whatever you want. So shut down the system. Let the operating system flush itself out. And you turn it back on. And then a sequence only becomes active, only becomes relevant when you insert a record. That's the only time. That's when it fails. And this is the mistake that comes out. Now, because I removed the entire table, it says reading at block 0. If it was damaged, real damage, it would be anything from 0 to whatever. Every file is comprised of a page. A page is 8 kilobytes. That is the size of organization of information. Every page has a header. That header describes what's on the page. In this particular case, it tried to read the header. The header said, couldn't find the information. So it stops dead. In the real world, if there was damage to a sequence, that's what you'd see. Because a sequence is a single table with a single row. That's it. That's not the case for a table. It's not the case for an index. So if anything happens, that's most likely what you'd see. And if you notice here, I did a little query trying to read it because it is a table. There's nothing read there. There's no information that comes returned. If you do this on a typical sequence, you're going to see information. You're going to see the definitions of the sequence at that time according to what it was doing to the table. But in this particular case, it doesn't exist. But you notice that when I ask for a definition to describe the sequence, it shows up. That's because the damage wasn't to the catalog. It was to the sequence itself, which is the redeeming feature. You're saved because you have an instruction that defines what you've lost. Let's carry on. Index. Let's suppose the sequence wasn't damaged. Now we go to the index. OK. Indexes, I take it out. I actually reproduce it with an empty file. Again, same thing. If you shut down the server and you bring it up, give enough time, you're going to get the error. If I do an explain, it works. Why? Because there's reference information. The reference information has not been damaged. If you do a select all and you get everything out of the table, the index isn't going to be used. It's a sequential scan. So you're not using the index. But if you use a criteria and the planner says, oh, I can use the index. Index is identified, and when you actually implement it, again, look at the error. It's the same thing, except there's a little more information as there is with the sequence. Same deal, same principle. Last example. Out of our table, pretend, sequence, index, they're there, they're constructed, not broken. So in this particular case, when I was developing the notes for this originally, I actually used Vim. I went in, I opened up a table, and I just made it messy. I deleted junk, I put in junk, I erased what I thought was the headers of the pages, I changed the contents of the information, and eventually, in this particular case, it said, oh, block 0, relation, base, da-da-da-da, doesn't work. Now, in the real environment, again, you could read a table, and depending on what the query is, you could be fine for quite a distance, depending on the size of the table, and suddenly, bang, it's going to stop dead. OK. So now let's look at our remedial. Indexes and sequences is the easiest two relations to fix. It's a multi-user system. It's basically common sense. You can, in the sequence, you drop it and you create it. Look at the two befores and afters. What I want to point out is the numbers of the relation file node. Dropping it, it meant it created a new file. That's what you did. So basically, whatever was there, wasn't there, was just toasted, erased, and you've got a new one. We go to the index. Same thing. Now, there's actually a variety of techniques. If you go into PSQL, you do your \h, and normally I'd start showing you the other documentation. But this screen has been so bad for me. I'm going to talk about it. I'm not going to change it because I might jinx it. You can rebuild. You could drop an index. You can create it. You could create it concurrently under load. Or you could just do a reindex. And reindex has different optional keywords. So you can do the database. You could do a table. You could do a column. And you could do something called system. Now, we're going to cover that system in a few minutes. If this is a production environment, it's up to you. It's judgment call. You're the one. You're the master of the system. What you want to do is something that has as little possible reaction on the system as possible. Let's suppose you've identified that there's a query. Suppose you really were able to figure out what range of the index was broken. Well, that means you could isolate what range is done. So in the real world, you do a hack, a kludge. For example, who here is not familiar with rewrite rules? Everybody knows what a rewrite rule is? OK. It's an old method of Postgres. It was used in Postgres back in the days when it was under active development, and it changed the rules of behavior when you gave an instruction and how it was implemented in the back end. At some point, developers decided to expose it to the DBA, which means that we had a way of abstracting an instruction and a command. If you write a rewrite rule, you could say, OK, intercept selects, but exclude this range of index. So technically, you could get away with working with this crippled index while you're fixing it. Again, if it wasn't for the screen, I'd actually show more. But this is sort of like stuff that you'll need to burn into your brain and think about. Opportunities. What I'm trying to tell you is, if you know enough, you can hack a system. And hacking isn't about breaking. It's about being creative. OK, here's something else. The system index. OK. Postgres implements the rules of SQL and CSQL by using system catalogs. System catalogs are the heart of the back of the back. It decides how it's going to implement things, how it records things. Give you an example. I once did a consult for DBAs from Fermilab. If anybody's here from Chicago, you might be familiar with Fermilab. And the DBAs actually supported Nobel laureates. And I'll tell you, if there was ever a bunch of spoiled kids, it's them. Give somebody the Nobel Prize, and they think they're God. So the problem is that they were screwing up in the databases. So we went through the routine. I showed them how if they went into single-user mode, they could alter the catalog in the intrinsic behavior and actually track what the DBAs were doing, what the Nobel laureates were doing. And it was such a wonderful concept that after they smiled, they got terrified. Because what if they'd been discovered? So it was just a nice little idea. Single user. What it means is you're trying to tell the server, OK, stop, don't allow anything else to go on, make only this connection the only one interesting. By default, when Postgres runs, it's multi-user. It has a number of processes that go back on. The catalogs, the guts, the back of the back cannot be changed in a normal multi-user environment. If you've got damaged indexes, you can't access them because they're under use. So you have to force it off you. So that means you have to bring it down and bring it up again in single user. Now this, actually, you'll find this in the reference material if you go into the Postgres material, and you'll find under the man page, or in the HTML, which is what I use all the time for Postgres, and you'll find a little mention on single. And it says, this is how it's done. By doing this, you're actually in an interactive session, equivalent to PSQL, except all the nice conveniences like help and semicolons and all different kinds of output modes, they don't exist. You're actually interacting with the system. Now, under typical use, you're going to see a single user mode when you create a cluster. You're not going to see it, but it's invoked automatically. It is useful for debugging, for developers. For DBAs, unless you write C, unless you're part of core or you're part of updating and upgrading Postgres, you're not going to do it, unless you're hacking the system. Again, the last part here, you can enter queries and the results are printed to the screens, which looks like this. So again, it's a lot of verbosity. Ooh, I still got time. Great stuff. Okay, so other than this little example, what you can see is that this command is now possible. All you need to do is you reindex. Remember the keyword system. You can rebuild all of the system indexes with this command. This is actually a nice thing to know. Postgres ages. It's like wine. Eventually, wait long enough, it'll turn to vinegar. What happens is, yes, you can maintain, you can update, you can rebuild every part of the database cluster except the system catalogs. But if you go to single user mode, you can extend the life, extend the performance a little bit longer. Now, every time, every iteration, Postgres updates and gets a new version, it fixes itself. It's better and better and better. To say that this is really a good idea depends on the version you're talking about and how long we've been using it, so we can talk about anecdotal. As a rule of thumb, anything that is said in a conference is anecdotal. It's very hard to come up with documented stuff because Postgres is a fast-moving target. Okay, the last part, the really important part. Sequences, indexes, yes, you can repair them. Yes, you can do it in real time. It's just a question of timing. But the tables themselves, that's another challenge. Okay. Here's something else. Has anybody ever invoked, and raise your hands, I'm serious, using the O switch? Okay. In other words, virtually nobody has done it. I use this implementation. Let me explain what it does. Postgres is Unix compliant. Unix compliant means it reads, it describes itself along a standard. It's not just a database. When you understand Linux, you understand the documentation. You understand command lines. You understand what's called a switch. That's the dash followed by the letter. 2 dashes, and that's a word. Those are rules. Those are golden rules and standards. Postgres follows it precisely. So if you can, I've said this before in other times. The perfect Postgres DBA is really 3 expertise. DBA knowledge, systems administration knowledge, and really, really an extra plus. And it's getting harder. C programming. The biggest advantage about knowing C is because the people who maintain Postgres maintain a program created in C, sitting on top of an operating system created in C. It's not C++, it's not Java, it's C. When you look at things a certain way long enough, you understand the tempo of how things are created and written. Know those 3 things, and you can command your salary. Know 2 of those 3 things, and you're at parity with the best. You know one of those things, and you're no better than an Oracle DBA. Okay, now, in the documentation, and that's where I'm going to refer to, and unfortunately, again, I would go back and forth with the documentation, but because I've had such a miserable time with the screen, I apologize, I just don't want to jinx it. In command line invocations, you've got these options, these switches. This is extremely useful when you're debugging or creating cluster environments. I've created multi-data center environments, and I control them all from one set of scripts, a command and control center, and I didn't bother updating or configuring the PostgreSQL.conf files. I used them right there in the command line. And since I was the master of the system, nobody else touched it. Nobody changes configuration files on a production system. This is ideal because you can change the runtime conditions, and it's only exists as long as you run that session. Once you restart it, it's gone. So in this particular case, switch O means option. Switch C means use the options that are found in the PostgreSQL.conf file. Now, before you start looking in the configuration file for this switch, 0 damage pages, I'll tell you right now, it's not there. You're not going to find it. But go to the documentation, and at the bottom, there's a link that says index. Click on it, and on your page when you get there, do a find. Look for 0. And you're going to find that switch, and it's under developer options. It's another section of the documentation. It's a developer option for special cases, and you're going to find a whole other collection of switches that are really cool and interesting that normal DBAs will not find. This is how you justify a 20% increase to your salary. So what you're doing here is you're going to instruct Postgres that when it sees a damaged page, just read it. Ignore what's on it. Just keep on reading. Don't stop. And that's what it'll do. It'll read and read and read and reassemble everything that you've got. So in this particular case, in the scenario in the consult I did, I had the machine shut down, brought it back up into this mode, 0 damage pages, and it was in multi-user. I didn't use it in single user mode, multi-user, and then as soon as everything was up, I didn't do anything else, straight to a dump. Take everything to a dump. Now, if you've got records with damaged pages, you're going to lose it. No big deal. But that other part, be advised, you're not clear out of the woods just yet. There may be damaged data. You won't know until you restart the system and you come up with your own regression testing. But at least the system won't fail. You may get garbage. You may get strange messages when you hit a query and get certain results. You may get unexplained results. But the system works. And then it's mechanical. It's just a question of vetting through the records, and you can do that with any process that's appropriate to your own environment. Here is a plan B. This is a plan that I don't encourage you, but I bring it up here to show you what could happen. You could run it with 0 damage pages equals true, and then you could do a fact and full, and you could do a reindex, and you clean everything up. You ever heard the term guilt by association? Any data that is identified as being damaged, any associated data, once you run vacuum, we'll clear that out as well. So if you don't dump this stuff before you run vacuum or analyze, you'll lose the data. And you'll never know if it was useful or not, but you will lose a chunk. So again, after you're done in this particular case, look at the little switches here. For those who aren't familiar, the M switch, there's 3 modes. Smart is when it'll only restart when the last client connection is off. Fast cuts the connections, cuts the sessions immediately, but they're clean sessions. Immediate is an emergency. The nuclear reactor is going critical. It doesn't even clean up the memory. It just shuts down. It's shut down in half a second. Doesn't matter how big your system is, it shuts down. Now, unless the police are coming crashing, and they're called Homeland, you don't have to worry about using immediate. You could just use fast to break those connections. Oh, good, still time. All right, so these are the caveats. They're a reiteration of what I've gone through. Again, wherever you see just indexes, it's implied sequences are there as well. So basically, damaged indexes, damaged sequences, you need to take the time. Understand what the behavior is. What does it represent when you have a damaged sequence or an index? You can come up with the proper method to drop and recreate them, however you choose. Common sense, creating the cluster on another machine. In a production environment, ideally, and it is becoming more realistic all the time, production machines and standby machines are actually the same configuration. A few years back, a lot of startups, they didn't have the budget, but times are changing. The Great Recession is forcing more established companies to do things that they never thought they'd do. They're actually trying to save money from surviving from the squeeze from the Oracle Uber. Executing a dump. Once you've got this thing loaded, especially with tables, dump it. Get it out of the system as fast as possible. Don't trust the system to stay awake or pay attention. Remember I told you about the vacuum? Well, you got something called auto vacuum too, eh? You might want to turn that off, or else you'll lose data on its own as it'll clean itself up. Damaged system catalogs in regards to tables, in regards to indexes, single user mode. It's the best way. Also, when you get comfortable, it's a great avenue for hacking. Opportunities, you see new behaviors. Here's something that you may or may not know. Postgres is old. A little younger than me, but there was a time when Postgres on production machines was only 32-bit systems. That meant ext2 was the rule of thumb as the file system. That file system, ext2, when it was the only file system of repute, had a limit onto how big a file could be. 2 gigs. 2 gigabytes was the limit on a particular file system, 32-bit ext2. To maintain data integrity, to maintain that the whole system would work properly, Postgres made a decision. All tables, all relations exceeding 1 gigabyte were split. Now, you remember that cluster I showed you with all the numbers? Large tables that go into the multi-gigabytes, they're going to have the OID, the number, plus it's going to be .1, .2, .3, .4, which is the paging of all these tables. It's the same table, but it's been broken up. And today, it still exists. The only way that's going to disappear is if you go into the source code and you alter it. Now, I haven't followed the lines. Maybe Robert Tree can talk about that. But I don't know if there's been any discussions about dealing with that issue. I would assume that we would still be cautious, that we would assume worst case scenario, worst case being the most primitive environment that we want to be able to match. So that means it's still going to configure to work on ext2 on 32-bit. Someday that may go away. Someday they'll go full 64-bit and there will be no more segmentation. But that's not today. Toasted tables. If you create a table, data type text, there is some things you need to know. If you look in the alter table command, in the create tables command, there are parameters that affect the memory policy. If something in a column, data type text, is less than a certain size, it stays in that table. It's not going to be moved down. You can order it to be compressed. You can order it to be uncompressed, expanded. You can explicitly order it to stay only as a toasted table, which means external. That means that data type becomes a pointer, a reference. If you have a damaged table with toasted tables, be advised, your toasted tables may still be okay. It's just that those pages that have those references, they're going to disappear. That may be an important piece of knowledge for you. If this was a longer session, maybe we could go through an example and go through the toast and just work it out. But you've got enough brains. You know that if it exists externally, you can develop a protocol to figure out what to do. Which brings me back to hacking. When I was a kid, there was no such thing as seedless oranges. One day, a farmer in Florida was pruning the trees, and he found this one tree. It didn't have any seeds. Has anybody ever heard the term of grafting? And I don't mean the corruption. If you take this technique, which is several hundred years old, I think it's 1,000 years old, you cut off a branch, you can put it on another plant, and it will grow. That's what the farmer did. That's why we have seedless oranges today. Over a period of time, he took the branches off the original tree, grafted them onto other trees. Those trees grew and prospered. Grafts were made of those branches, and within a period of time, all we've got now are seedless oranges coming out of an orchard. Grafting and pruning are terms I'm going to use it to describe what you can do with this understanding of relations as files. Suppose you've got a multi-terabyte table. Suppose you want to create a copy of it, and you just want to play with it. You need to do some investigations. Well, here's a little trick. Create the table definition, match it exactly to the exact table, identify the relation file node, and identify the relation file node of the existing table. Copy it and rename that file. And suddenly, you've got a new system. And because it's on the operating system layer, you completely circumvented the entire Postgres authentication and validation method, which means you have created another table like that. Now, is this perfect? No. And anybody who works in core will tell you that. Because one of the things that is also included in those tables are the system columns, the hidden columns of reference information describing that table in detail. Does that mean it's broken? No. It means you have an opportunity of doing something that maybe would have taken you forever to do before. Something to think about. And that's it. And I thank you for my educational tool. Questions? Yes. Oh, yes. It's slow. It's slow. Well, okay. The latest versions of Postgres, Magnus, who was here with Magnus this morning? Did you cover the recovery on 9.3? The dumping and recovery? The restoring? Yeah. In case for those people that weren't there, the latest version of 9.3 actually takes a page out of Oracle, which is it has multi-streams of saving relations to the hard drive. However, not multi-streams for one table. That doesn't exist. Yet. On the other hand, if I wanted to, I think that might be an interesting little hack that you might be able to copy quickly using your own techniques. Using command line utilities on Linux, and whoosh, it's interesting. Yes?
How do you deal with visibility?
With what?
Visibility.
As in?
When you're copying files around like that.
Oh, well, again, this is hacking, okay? I'm not saying that you do this in production. This could be potentially useful. I'm saying this is an opportunity to expand your imagination. Look, no. Think. There are three kinds of people in industry. Those who are good enough, just good enough to get what they want. Those who are good enough are considered experts. And then there are the experts. And the experts, again, literally, are people who are not, well, respectful of risks. Yes. But you're willing to think out the box.
Have you actually tried doing, like, ensuring that the source table is frozen or something? Is what we're trying to do?
I have not found a real use case that required this so far.
Oh, okay.
I'm not saying it's impossible. But for example, like, not on the job that I'm on before, but before when I was working for the startup in Seattle, I needed to make an active-active master system between Atlanta and Seattle. And everybody knows who's worked with Sloaney, that's master-slave. Well, didn't stop me from using Sloaney, I just hacked it. It worked. It worked because T-Mobile didn't complain. Okay, any questions? Other questions? Yes?
Is there any other utility that can identify the back pages?
Any other utility that can?
Identify the back pages in the table.
Oh, that can deal with and process it? There are no processes or utilities part of Postgres that I am aware of that can process damaged pages in this manner. The knowledge that I've just shown you, if you had the ability to learn about the intimacies of a page, if you could, actually there are modules in Postgres that could read individual pages and blocks. But if you had that knowledge, which means basically the capability of implementing a solution in a programming language, ideally in C, you would arguably have a way of creating a utility that could do this on its own and would probably be very, very fast. Yes?
What do you think about checksums?
Seriously, I think checksums are really useful, yes.
Well, I mean, 9.3 actually has, I mean, they have checksumming happening now. You know,
Yep.
for when you hit plus, so.
Well,
That possibly you could address some of these concerns around.
integrities? Yeah, if you kept a record of a data cluster, you could use it. It makes a hell of a lot of sense, yeah. It makes a lot of sense. How many people here have used the SSL capabilities, the encryption capabilities of Postgres? Have you used the checksum capabilities there in the encryption? I'm not saying that it's the way I suggest you go, but it's, again, it's knowledge of a concept. By understanding the encryption, you understand there's all sorts of concepts. Let's see. How many people here have heard of a utility called Jack the Ripper? Or not Jack the Ripper, John the Ripper. Okay, we got a few people. John the Ripper is a command line utility meant to reverse engineer MD5 checksums. MD5 checksums with the username in Postgres is how they hash the password into the catalog. If you were a super user and you had access to the system catalogs, the PG Shadow, and you used John the Ripper, by knowing the user account name, you could reverse engineer the password. And if they're really silly passwords, you could probably decrypt them in about 3 seconds, depending on what the silliness is, if it's less than 4 characters or whatever. It's a great way to find out security. Again, it's another example of being creative. Other questions?
I just wondered, if you didn't mention about rules, no, it's setting rules for any situation.
No. Again, I'm just talking about a specific use case. Now, write-ahead logs is part of that process of data integrity. First, it writes to the wall, and then at some point else, the scheduling, it writes everything else to the actual cluster, the database. I didn't deal with it because that wasn't the problem I was dealing with. The thing about something like Postgres is that it does encompass so many ideas. And I wanted to limit this to really be very clear on just a few ideas. The walls, there are experts here who are really, really good, but you're talking about how it's written. And right now, I would say that the stage of maturity of the tools that we have to diagnose walls, there are some there, but I would consider them a starting point to be able to read the walls. Like, there was some initiatives started a few years back of compressing walls dynamically. And there was other ways of reading the walls, like the replication now that's being done. It does read the walls. And I remember a talk where somebody had actually parsed using the replication command line utility to isolate queries and additions to particular relations. Now, it was like taking a needle out of a haystack, a very large haystack, but he was able to filter it. So I could see that at some point, somebody's going to come up with a better filtering mechanism at source to be more efficient. Okay, so I think that's about it. All right, well, thanks for the opportunity of letting me talk. I love to talk.